So, am I audible?
Yes, sir.
Okay. Are more joining or only you two will join today?
Sampath will join, sir. I'm not sure about
Okay, we'll wait for 2 more minutes. Then we'll start.
Yes, sir. Oh, Sampath will join.
Is in now?
Yes, sir.
Okay, speak with your
Oh,
background.
Nitish joined.
Yes, I did. I was writing. I couldn't join the first class, but it turns out the first class wasn't there.
Hey, first
Got
class
lucky.
didn't even happen. First class didn't even happen.
That's what I'm saying. I was not gonna attend that class, and luckily that class didn't happen.
You're the luckiest guy alive there.
Yeah. I was
I'm
writing.
saying you're the.
I finished Tamil Pada, and I'm almost finished with English. So we got
Did you
that
finish
text.
your projects that fast, huh?
Yeah, Tamil I have it I have it right now. Like I finished my Tamil. That quick.
Tarun join. Sir, everyone join.
Good afternoon, sir. I was actually happy that the first class only me and Pongwell were there. So.
It didn't even happen.
Unluckily,
Look how many I wrote Tamil. I have to stick the pictures though.
project.
Can you see the screen?
See, Tamil. I finished Tamil.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So we got the textbooks, sir.
Okay, you got your textbooks?
Yes,
Wow.
sir.
Just got
Yes,
it.
sir.
It looks so cool, sir. It looks like an anime movie.
Yeah. The theory of Avengers is given there.
Yes.
Sir, today our ma'am taught us about contact force, non-contact force, and she gave some examples like electrostatic force,
Extension,
magnetic force for
collision, like that.
non-contact, and for contact,
Okay.
action force.
So we have done till frictional force. And okay, we were discussing contact force, right?
Yes, sir.
Yes.
Frictional force we finished. Sir.
In fact, we have discussed the frictional force. Okay.
Yes.
One
We'll
second,
be
sir. I'll take my
discussing
book
both.
from my very big book rack.
Okay. So we'll discuss more deeper into this contact force. We'll discuss some more examples, and then we'll be moving on to the non-contact force, right?
Yes, sir.
Everyone ready? Shall we start?
Sir.
See. Next we have normal reaction force. Normal reaction force. The kind of contact force. What is normal reaction force? See here, like you have, this is a table, let us say. Okay. This is
There's
a
a
table.
book on top of it.
Yeah. There's a book,
And the
a
book
block,
doesn't
anything.
fall down. Why?
Okay. Now see here. So Earth is here. This is the surface of the Earth. Okay.
Yes, sir.
Now tell me, this Earth will try to pull this book towards itself or not?
Yes, sir.
Yes, sir.
Earth is very greedy.
But like now this, due to the Earth's surface, this book is trying to push this table downwards because Earth is pulling it.
Yes, sir.
Agree, everyone?
Yes, sir.
Yes, sir.
In this is the action. This is the action. In reaction of this, we get a force from the table surface. Okay. In reaction of this action, we get a force from the table surface to the book. Okay, and both are same. That's why they get cancelled each other, and hence the book does not go down. Understood?
Yes,
Yes,
sir.
If you If you see this, if you see this in detail, I'll show you. See what happens. If I just place these above, okay, I'm not making the contact here, but you assume that the contact is there because I want to show you something different. See here. Now the book applies the force on the surface, okay, on the surface of this table downwards. This is force by book on table, okay. In reaction, the surface of the table applies the force on book. See, this is force by table on book. They both act on different bodies. This is called action reaction force.
Yes, sir. That's
Okay.
what we did today in school.
Got it? So there's a difference between the action reaction. Action reaction force is not something like which accounts on the same point. They occur on different surfaces, yet the magnitude is equal. FBT, force on book by table, is equals to force on table by book. The magnitude is equal. Okay, so when you consider the whole system, if you're considering the whole system, then they are like same and in opposite direction. That's why they'll be getting cancelled each other, and they'll be getting to be zero. But if you're considering the system as the book only, so for book this part is not zero, FTB is there, and if you're considering the table only, so table is not zero, FBT is there. Okay, so the
Yes.
question may come for you like, if the action reaction forces have the equal magnitude, why don't they get to be zero? Because they act on different
So I
surfaces.
have a doubt, sir.
Yeah.
So when the let's say I keep a lot of books on the table, like let's say I keep like 10 to 20 books on the table, and the table is not able to produce the equal amount of force as the books. So
Fall down, it'll
Hmm.
break
then it
in the
is-
middle.
the table will break. So
You don't have that many books to
But-
place.
I know, it's just a case, Dad. I'm just talking about if.
Buys 100
Go on.
cartons of milk in the store.
Go on.
But if like let's say the force on the books is not if the force on books is less than the force applied on the table, what will happen, sir?
See,
Not doing
those things doesn't happen. For example, I'll tell you. Let us say this is the table, okay, and here you are applying a book whose weight is let us say that the mass is 10 kg. 10 kg, that means force is equals to mass times acceleration. Okay, this is a formula. Force is mass
law of
times
motion.
acceleration.
Second law of
Okay.
motion.
And yeah, and here acceleration is what? Here acceleration is acceleration due to gravity, that is g.
9.8 meters per second.
10 into, we are considering nearly 10, so it is
Not 10.
100.
Okay.
10,
Listen everybody,
100.
it's 100 Newton.
Yes.
Yes.
sir.
Listen everybody, it's 100 Newton. Okay, now if I say that this table can resist up to 500 Newtons, this table can resist
So
up to
5
500
books it can bear.
that
Oh,
doesn't
after
mean,
500 Newton, it's
that
just
doesn't
will
mean,
hold up everything.
please listen here if I'm explaining, that doesn't mean that if I'm putting a weight of 100 Newton, this table will provide a resistance force of 500 Newton. This is not there. This is not there. This table can resist up to 500 Newton, but the reaction force will be equal to the action force. If it is 100 Newton, you are 100 Newton.
Book is
So
more
does
than
it
500
make the
Newton.
books
The
like
thing
push
is-
away?
Sir,
Does it push the book?
my doubt was what if
First, let me
what if
explain. First, let me explain.
yes,
Now, if I put another book over it, that is again 100 Newton. So it increases by 100 Newton. Here also it will increase by 100
Yes, sir.
Newton because this table can resist up to 500 Newton. Now I place 4 such more books. Okay, 1, 2, 3, 4, and 5 books. Okay, now this is 500 Newton downwards, and the table can resist, so it will produce 500 Newton upwards. Again, now if you increase the book one more, so the pressure below is 100 Newton more, that is 600 Newton. But the table can resist up to 500 Newtons only, so the resistance force will be 500 Newton, and there will be a difference in the forces. Okay, that is 600 minus 500, so net force will be acting downwards, that is net force of 100 Newtons, because 500 Newton is getting resisted. So with that 100 Newton force will be the cause of falling, this cause of these books to be fall down. Got it?
sir, like will they break the table?
Yeah, Of course.
Sir, but like it is different when we don't stack the books on top like that, and instead of doing that, spread it all over the table means it will be like it will not fall
Yes,
down,
sir,
right?
then it will be different, right, sir?
No, why it will be
No.
different? That is
Sir,
just your
because
thought
Instead of
process.
stacking all
area
the
is
books,
spread out, right, sir?
if I spread all the books,
You are, if
table
you are,
won't break, right? Sir?
if you are placing 6 books at different places, aren't their magnitude the same? If you place them on the stack as one over the other, they'll be providing the
Yes, sir.
same force now.
So, but it has no point to break, right, sir? It can't
That
break at
no,
a
no,
specific
it will
point.
break at a point that is to be calculated. That we have that chapter in further classes, center of gravity and center of action of point. So that will break in between those of the that point. So you don't have to go deeper like that. You just feel that force reaction force acts on different bodies and they have equal magnitude. Okay, so normal reaction comes when we have anything that is kept on a surface. When the body is placed on the surface, the body exerts a force downward equal to its weight, and the same force is reflected by it as normal force. Got it?
Yes, sir.
You write this down. You write this line down. When a body is placed on a surface, when a body is placed on a surface, okay, the body is placed on a surface,
Sir.
it exerts a force due to its weight. Downwards. And the surface also produces a force on the body which is equal in magnitude. But opposite in direction. Called as normal reaction force. Okay, done, everyone?
Yes, I'm in the last line.
I'm done, sir.
Okay. We have tension force. Okay, so what is tension force? You must have seen something hanging on a string.
Yes,
Okay.
Yes,
sir.
sir.
Everywhere. So again, the earth is pulling this object and it has got some mass, so its force will be m times g. Okay, that is equals to weight. Okay, weight and mass are two different things. Are you getting my point?
Sir.
Yes,
Weight is
sir.
a kind of force, and that is mg. So when we say what is the weight of that
Constant
object and you
gravity.
answer 5 kg, so that is different. That is wrong. Weight is to be answered in newtons, because m into g will give you
Yes.
the answer in newtons. For example, Sankalp has got a weight, mass of, let us say, 40 kgs. Okay, so that is the mass. When he is standing on the earth, he is getting pulled by the earth's gravitational field with an acceleration of g is equals to 10 meter per second square. Everybody know this?
Sankalp is 400
So
newtons.
400 newtons. That is the weight of Sankalp. So whenever
9.9.
Sankalp, you weigh 400.
9.8, sometimes it see g
Okay,
varies
that
over
thing
the
is
earth's
less.
surface. G is not constant. G is 10 over on the poles. G value is different on the poles. On the equator, G value is 9.8 around. So it varies. So generally we take the value as 10 generally. But in question it is given to you whether you have to take 9.8 or 10. Okay. So if nothing is given, we take it to be 10. Right. So
How
tension
can
force
we
is what?
find our mass, sir?
Mass is something that you have to calculate on the machine.
The machine shows your mass.
The body.
The machine shows your mass.
The machine shows your mass by cancelling out the gravity.
Okay.
Force
So
acquired
if
by
I
the
divide
string.
10 to my weight, that's my mass.
No.
Yes.
Yeah. No. If you
Wrong,
measure
wrong,
anything
wrong.
in kgs, that is your mass.
What's it?
The
Okay. So
weight machine shows
what
your
the reading you are
mass.
getting- whatever the reading you are getting in the machine, that is your mass.
Okay.
Okay. Understood, everyone? No further explanations required.
Yes, sir.
No, sir.
Write it
So,
down.
can you, 1 second, sir. We'll just write it down.
Write it down.
Could you read what you have written?
This one. This line.
Yes, sir.
The force acquired by the string when any body is hanged by it is tension force.
Yes, sir. Finish, sir.
Everyone, tell me. Done, everyone?
So,
Yes,
1
yes,
second, sir. I'm almost done.
Should we draw that diagram?
Draw these figures also.
So should we draw that diagram?
Yeah. Figures are also important. When they ask you in the exam, you have to show everything.
So even for normal reaction force. Yes, sir. So should we draw a diagram for normal reaction force also?
Yeah, all the diagrams are important. You have to show
So
them
1
in the
second, sir, then
exam
I'll
if they
do
ask you. Okay, proper way. In
Okay.
science, you have to draw more than you have to write. Then only you'll
which
get
one
marks.
should
You
I
have to
draw,
show
sir? The
everything.
table book one or the FDB that one, sir?
Both of them.
FBT
Both
is
of them.
equal to FT.
You
Both of
draw
them.
all of
Okay.
them. If something is unnecessary, I already removed that. That Sankalp question that I made here. I remove everything that is unnecessary.
So on the image, the string gives the force on upward direction and the box gives the force on downward direction.
Yeah. Even here you can understand the same thing. If I am considering this point where the box is attached to the string, so the box and this is the string. For box, the string is pulling upwards and the box is pulling downwards. This is the force. Got it? So that's why wherever we show the tension force, we show it like two arrows in opposite direction in any place.
Yes, sir. Done, sir.
Everyone, shall we move further?
Yes,
So,
sir. Done,
1
sir.
second, sir. 1
Yes,
second.
so 1 second.
I was not saying that Sankalp's question was useless.
We didn't
Yes,
understand
we-
it like that, sir. It was,
Because I already know
it was like,
No, Sankalp, just your friend Nitish was laughing. That's why I answered him.
it doesn't matter, sir. I don't
Take
take it
care of
serious.
it.
Yes, sir.
Okay, done everyone? Shall we move further?
Yes.
So I think he's
yes.
finished, sir.
Yes, sir. Done, sir.
Okay. Tarun, done?
Yes, sir.
So next that we have to study is the spring force. It is very interesting.
Wait, what?
Spring
Rigid force.
Elastic potential energy.
Oh, okay, okay.
Naveen.
Force by a string.
Sorry.
Or spring.
We have a lot of definitions in this chapter.
You just have to understand the things. You don't have to remember anything. In physics or in chemistry, you don't have to remember anything. You have to understand the things. Okay, if you understand what is spring force, what is tension force, then you can write it by yourself also, isn't it?
If you're smart enough.
Yes. Sir.
Okay, now see here, all of you must have seen the spring.
Yes, sir.
Yes,
Yes,
sir.
sir.
Something like this,
Yes, sir.
right? It is generally present in the vehicles and some toys also. You must have seen this. So what is there? It is a coil of some material, maybe anything, steel or something like that. So when you push it
Yes,
or
sir.
pull it, okay, it either gets compressed or either gets contracted. Okay, so it can be like, if we pull it out, so it will be something like this.
Yes, sir.
Yes, sir.
What is
Agree?
those lines you have drawn?
The
Which is this
wall.
one?
Rigid support.
This shows the rigid support. In science, everything has got some notification. So rigid support, that means it is either attached to some wall or something like that, which is not moving. Okay, so you'll be getting used to these lines in further studies in 10th or 11th, like that. So see here, if we like pull it towards ourselves, any spring, so what happens? It creates some tension inside itself. Okay, and it tries to pull you back towards its normal position. Okay,
Yes, sir.
are you getting my point? That is called the
Yes, sir.
restoring force. Restoring, because it wants to restore its original configuration. Okay, and restoring force has a characteristic that how much deformation you will create, in that respect the restoring force will also increase. Like if you are strengthening it for 10 centimeter, so you'll get, let us say, some amount of restoring force, and if you're strengthening it to 20 centimeter, the restoring force will also increase. Are you getting my point? So restoring force is directly proportional to the displacement that you have made. Okay, so we can say
Yes.
the force
Oh, yes, sir.
created on the spring when applied to any deformation is called a restoring force or spring force. Okay, one more point you add. Restoring force is directly
Sir,
proportional
may I
to,
just drink water and come?
yeah, no problem, directly proportional to restoring force is directly proportional to the deformation, or yeah, deformation, it can be said, deformation. Or you should write magnitude of displacement. Magnitude of displacement.
Sir, let's say I pull the spring by 100 Newton. So the restoring force should be negative 100 Newton, sir.
Yeah,
Okay, sir.
exactly.
Could you repeat what's restoring force?
Restoring force is like when you pull. Have you ever pulled or pushed any spring?
Yes, sir.
So it doesn't it feel quite hard to push it or pull it or change its displaced, like give it some kind of displacement? Isn't it quite hard?
Yes, sir. So it's
And
actually quite.
that stiffness increases when you increase the displacement. Like if you are pulling or pushing any spring for 5 centimeters, so the spring will try to restore itself. Okay, so it will apply some force against your force in opposite direction. And if you will increase the displacement, that force will get also increased. Okay, and that will be in the opposite direction. So how much displacement that you provide, thus the restoring force will be opposite to it and in the same magnitude. Okay.
Yes, sir.
Till here, everyone.
So what is the
Yes,
last
sir.
one, sir? What is the last one? After
Last time,
magnitude
restoring
of-
force is directly proportional to the magnitude of displacement.
Sir.
Okay. The last that you have to study here is
Magnetic. Or
force
gravity.
exerted due to collision.
Oh, okay. Sorry, this is contact force. Gravity is not contact force. Sir, sorry, sir. I thought it was not.
Okay. So you write in there, when any two bodies collide, they exert equal and opposite forces. Opposite forces each other. That is the force generated. You can see anyone, like if somebody is running from here, another one is running from here. If they collide at this place, so this will also get some kind of force, and this will also get some kind of force. So finally, they'll be here and here, isn't it?
Yes, sir.
It's the third law of motion. Every action has an equivalent
Has
opposite
Have you ever
equal and
collided with
opposite
a friend
reaction.
while running?
Yes, sir. My friend Nitish once collided on me. I fell in school. Great.
That was like 2 years ago.
I've
Nah.
had very rough. I've
Very
actually
cool,
had a
sir.
very rough experience of collision force, sir, because I fell from like 1.5 floor, a fountain which was 1.5 floor, and I got a 9 stitches on my
How are
chin.
you still
where I
alive,
hit
da?
I know. How am I still alive?
1.5
I
floors,
had
sir.
2 stitches on my head, had a
One man.
fracture, and I still survived somehow.
Only 2 stitches, sir, for 1.5 floors.
Made of steel.
Yes. Wha-
Iron Man.
No, sir.
That
I
is
got
this-
two stitches. I got 2 stitches in my head, and I got 8 stitches in my chin, like chin tip, and I got one fracture in my left hand.
That is huge. That is huge.
What did you do that you fell from 1.5 floors, sir?
I was an idiot. I was playing dodgeball in the terrace with no fence.
You're now also idiot, da.
He was being very naughty, so his parents pushed him.
You played dodgeball in the ceiling, huh?
Yes, sir.
Yes, sir.
Sir, thank God it was a granite floor, sir. If I fell on my chin,
Granite
Thank
floor.
God it's a granite floor, huh?
If it have hit
Granite
a
floor
Thank
is the
God.
hardest,
floor or
da.
The granite floor. I could have considered thank God for sandy floor or something like that, but not for granite
Thank
floor.
God he was alive, sir. No way. It's a granite
No, sir,
floor, 1.5 floors.
Thank
Sir,
God you
the
are alive.
worst case scenario. Sir, the worst case scenario was a cement road or a rock, sir. Because if I would have fallen in the opposite side, I would have
Worst case
even
scenario is lava.
So,
Granite is
that's
also
not
a rock.
possible, da. Worst case scenario.
Okay,
You will have to respawn.
give attention here, everyone. Non-contact force. Non-contact force. Non-contact force. There is no contact between the forces applied for the body, right?
Yes, sir.
Yes, sir.
The forces experienced by bodies. Experienced by bodies. Even without being. Even without.
Sir, we already wrote the definition for it. Sir.
You've written?
No, sir, we didn't.
No. Let's do the diagram.
We only do the diagram.
Physical touch are called non-contact force. See, this chapter is of great importance. You have just started with this chapter. Okay.
Yes.
Anyone to do MBBS like NEET or JEE here?
Sir.
Definitely not
Very
the
interesting
medical
in-
side.
Engineering or medical?
Need, sir. I want engineering. Not need.
Even for engineering, even for engineering. Yeah, even for engineering, this chapter is something like really huge. This page PDF is there, this much. Your book size PDF for this one chapter only. You have to
Oh my
read
God.
so much. And all of those are concepts, no theories. Different types of questions are there. Even we have questions on non-contact forces, like the normal force that you are studying, you have to calculate the normal force. The friction force is huge. Different types of friction forces we have to study. That is the limiting friction, the static friction, kinetic friction, different types of frictions are there. Then for tension force, yeah, for tension, we have to exactly calculate the tension on any pulley or something like that. Okay, so this chapter is really huge, and you have to pay attention to each and every word of this chapter from the starting only if you want to clear those exams. And this is of great
Sir,
importance.
where did you study?
Any questions? Pardon?
Where did you study, sir?
I could not hear that. Pardon?
Where did you study, sir?
Where did I study? Where I'm studying, or where did I study?
Are you studying now?
I'm still studying. I'm a student itself. I'm in NIT.
Where,
I'm
sir?
still doing my BTech.
Oh, I thought college.
It's in IT, sir.
NIT Jamshedpur.
Yes, sir.
Oh,
Sir,
Oh,
actually,
college.
sir, I
NIT is college, sir. National Institute of Technology.
I know. I'm asking.
sir, I knew you were in college from the first day because you look too young, sir.
What?
Okay, done everyone? Shall we move further?
Yeah.
So types of non-contact
Yes, sir.
forces. The first of that kind is
Gravitational.
gravitational forces. Yeah, everybody know this?
Yes, sir.
Gravitational
Yes,
forces.
sir.
Yes, famous.
Gravitational forces. Can anyone explain the difference between gravitational forces and gravity?
The gravity is
Gravity
the
is
amount of force up, like towards the pole applied on an object in a specific planet or a exoplanet, like that. Gravitational force.
It doesn't have to be poles, right? It doesn't specifically has to be poles.
I never said poles. I said like
Said
the
poles.
core, like.
Okay, now see here.
Okay.
Gravity is when quite partially you were correct, Nitish. Gravity is something like if any planet is attracting some other body, any other body. So that is the force of gravity. And gravitational force, you'll be surprised to know, acts between every two bodies present in the universe. Every two bodies.
So
Gravitational force says that any two bodies present at a certain distance applies an attractive force towards itself. This
Sir,
means
even this
that
pen has gravitational
even your
force.
laptop or screen, whatever you're writing on or you're studying with, that is attracting you towards itself. Even the back wall is attracting to you towards itself. Okay, even the nearby trees are attracting towards itself. Are you
Yes,
getting my
sir.
point? Everybody,
Yes, sir.
even the rock, even if a rock is there at any place, that is attracting you towards
Because
itself.
Earth is so big, like its
Yeah,
mass,
and
its gravity
simultaneously
dominates
you are
everything.
attracting that body, and simultaneously you are attracting that body towards yourself. So this is gravitational force. And if this attraction force is between a planet and another body, that is called as gravity. Got it?
Yes.
Yes, sir.
yes, sir.
What happened, Sankalp?
No, sir. Like my
He's
mom
mad that
used
I
to
was
tell
right.
that. My mom used to tell Sankalp, like, you're getting the computer is attracting you. You should not like get addicted to it. So what you're
It's a
saying is
metaphor.
like, yeah, but now it's true.
Yeah, it's
Mhm.
true. So why
Yes,
you are not getting
it is.
attracted? Because the force is really small, very small force is there, and we can resist that. That's why we are not getting attracted.
Sankalp is not able to resist.
Oh.
Nay, I did say I am able to.
Resist.
Will be shown up in the next exam. I need full marks from all of you.
Yes, sir, you got.
So,
Sir, in
So,
what?
unless we don't have the first chapter, we are good in this exam, sir.
The first chapter was easy. Yes.
Every chapter is easy if you study.
So what did you write in what?
Where? In universe,
first-
every particle attracts the
in
other
universe.
particle due to its mass. This force.
Sir, is it true that in space, when we are in outer space and like we are just floating and moving all around? Is it because of gravity, sir?
There is no gravity.
No, gravitational force.
Sir, there
It's
is
due
no
to
gravity
Zero.
in space, sir.
Yeah, gravity is not there at space, but gravitational force is there. Gravitational force is there. Sun is attracting the Earth at its place. Okay.
Not even
The
a
So,
moon
very
is
far
even if I'm in
away.
space, even if I'm in
Are you getting-
space, like the Earth slightly attracts me towards it.
very
Yes,
small
like,
force, that is because
sir,
you are at a
is
great
it
distance.
true that wherever you are at the universe, let's say, let's take Earth as the common planet, sir, and I go like many light years away from Earth, and the Earth still attracts me, but the power, like the gravitational power, is not much.
In
Yeah,
the
that is
Earth
based on the
attracting you,
distance.
the closest planet or
Inversely proportional to the
the
distance.
celestial
How much
will
far you'll
attract
go, the force will decrease in that proportionality.
Yes, sir.
You know,
Sir, but the
exact
force will be
formula.
there.
Exact formula is G m1 m2 by r square. If any body's m1 and m2 mass is placed at a certain distance r, then that force is G m1 m2 by r square. G is a constant having the value 6.077 10 to the power minus 11. Okay, so if you will increase the distance r, this fraction will get reduced, and you're talking about millions of distance to see how small that force will be. So you don't have to write this.
Yes,
This you'll study
closest
later.
celestial
even
will
more
start
by a
attracting
millimeter.
Pankaj, sir.
Hmm.
So the closest
Understood?
celestial will start attracting Sankar, sir. Like a star
Everything, everything attracts.
Everything will attract me, but the one that has the strongest will attract me first.
Okay, written this.
Yes, sir.
One second, sir.
Yes, sir.
We have
The black hole
electrostatic
will have
force.
a maximum gravitational force.
What's the physics homework?
Electrostatic force. What is electrostatic force?
So
Sir,
I don't know.
force that is generated due to the movement of electrons.
Not movement of electrons.
Collage.
Sir, due to the charges, sir.
Yeah. Static, electrostatic. See, two things are there. Dynamics is something that is related to the movement. Static means they are at rest.
Yes, sir.
Yes, sir.
The stationary.
Tiny. So what is that?
force-
Any? So the force present between any
Any two of the any
two,
two charges kept at a certain distance kept at a certain distance is electrostatic force.
Force between any two.
Any two charges
Charges.
kept at a certain distance is called
1
electrostatic
second,
force.
sir.
Okay.
Is there
Point number
anything
1.
called, excuse me, sir.
Hmm.
Sir, is there anything called electrokinetic force?
No. There's nothing called electrokinetic force.
Sir, is it because like the charges can't attract each other when the
Of
object is
Newton
in
himself still didn't discover it.
Now see, when objects are in motion, they exhibit little bit different properties. When objects are at rest, they exhibit little different properties. See, when objects are at rest, they can produce the electric field, electric potential, and electric force. When they are in motion, so they produce the magnetic field. Same these charges, when they are in motion, they produce the magnetic field and the electric current. So we study both the cases, objects at rest and objects in motion. Okay, but at different aspects we have to consider there. That is there in the further chapters. When you'll studying, you'll be getting everything in detail. I guess in class 10 we have little insight of it, and more is there in class 12.
Done.
sir.
Everyone done?
Yes, sir.
Yes, sir.
Okay. Last thing that you have to do in this non-contact forces is
Magnetic.
your no, not magnetic. Yeah, magnetic force. Magnetic is left now. Yeah, magnetic is left. Magnetic force. Okay. What is magnetic force?
So when two poles, unlike like poles, repel each other, and unlike poles attract each other.
When a force is created because of the magnetic field of two objects,
Force present between two magnetic poles. Kept at a certain distance
Like,
is called.
how is like light and electricity not a part of this forces, sir?
And how it should be a part of?
So like they do like emit a bit like slight forces, right, sir?
Hmm?
Use
Like,
light to
they
move
do
your objects around.
So like they do emit a slight forces, right, sir? They do.
No.
What kind of force?
Wait, they don't.
They don't.
Mean what kind of force?
So he's telling like if you blow a really, really powerful torch on an object, the object will move a little bit.
Yeah, you're talking something different. What kind of force
No,
you
sir.
think that a light produces?
Newton.
Momentum it transfers. When you go into deep now, you'll get something like this. He's not totally wrong. Light emits kind of momentum on any surface, and if momentum is there, change in momentum causes force. But this is something I cannot explain to you because you have not studied the dual nature characteristics and wavelength and intensities. So these things are kind of inexplainable for you guys. You will get to know all these things in future. It's good that you show interest. It's very good.
No, so I just read it in a book somewhere, so I just want to ask it.
Yeah, that
Why-
produces momentum. Light, when they strike on any object, it produces momentum, and change in momentum with time is force. This is the second law of motion. Sorry, second law of motion, second law of force, I guess. And these things are there, but for that I'll have to explain you everything. The dual nature characteristic is there, the atomic nature of light, and then the wave nature of light, Bohr's atomic theory, and lots of things.
Yes,
Those
sir.
are things you'll get to know all these things. Write it down, everyone.
Yes, sir.
Yes, sir, done.
Done.
Yes.
No, 1 second, sir.
This are contact and non-contact forces is completed. One thing you write here, one thing in the gravitational part you write, everyone write there. I'm just writing it here. It is always attractive. Always attractive. This is its property. This is always attractive.
Like you cannot. It's not under
Escape from it.
In a note you write,
This happens.
the magnitude of non-contact force decreases with increase of distance between them and increases with decrease of distance between them. Okay.
Yes, sir.
In short, you can write it varies
So it's
inversely.
just like gravitational force.
Inversely as the square of distance between them. Told you, no? The non-contact force, I'm just writing non-contact force like this, is inversely proportional to the square of distance. I told you, not the force of gravitational force F is G m1 m2 by r square. Magnetic force
Yes,
is
sir.
mu naught by 4 pi I dl sine theta by r square. Okay, mu naught by 4 pi I dl sine theta upon, this is the formula that you're studying in class 12, r square. So you can see here r square is common here. Even this electrostatic force is k q1 q2 upon r square.
So what is R, sir? The distance between two objects.
Distance between them. Yeah. So with increase, you can see that this r is present na in what shall I say? This r is present in the denominator, and if something is present in the denominator, it decreases the value, right?
Yes,
Sir, so this law is the law of force of gravitation, and Newton's law is a law of force on motion.
We didn't even start Newton's law yet.
Yeah, that is
But
different thing.
yeah.
That is different.
Yes, sir. Like Newton. Yeah. Well, whatever you're saying is on gravitation, right?
Gravitation, magnetic force, and electrostatic force that follows inverse square law. You write this down. This is important point. Okay, inverse square law. It is said inverse square law. That means these three forces are inversely proportional to the square of distance between them. Okay, inversely
So
proportional to
what
the
is
square
right
of
there,
distance. Where? Read the
increase
previous
of
line.
distance between
Increase
them
of
and
distance between them. and increase with the decrease of distance between them. If you decrease the distance, sorry, if you increase the distance, so force will decrease, and if you decrease the distance, the force will increase.
Oh, yes.
This chapter is so big.
How big, bruh, it's so easy.
Because
It's
you
not
didn't
even
learn
one-third.
actual part
No,
of
this
laws
is
of
not even
motion yet.
1/4. It's not even 1/4 of the chapter.
You didn't even start learning the actual topic.
Yeah.
Not all this, the chapter is over, right?
No, he
No,
said
sir,
non
the
contact and
concept was
contact
not-
force
It is
is
not
over.
even started.
Oh,
Chapter has
okay,
not
okay.
even started.
Okay, I was
How
like, the
many
chapter
pages
is
are there
over.
on this chapter? How many pages
Like
are there on
3
this
pages in the book for each law of motion. And then there's like more.
Finished, sir.
Yes,
Done?
sir, done, sir.
Okay, now we'll be starting with the laws of motion. Okay,
Yes, sir.
so Newton's first law of motion, and that is called the law of inertia. And this is very easy.
Yeah.
All these three laws of motion are very easy, and some students quite feel sometimes that they are hard, or they cannot be memorized, or they cannot be understood. They just cram it. Okay, but I won't ask you to do anything like this. Okay,
It's like
this is not getting
the concept is so easy. Just give it in long text.
Excuse me, sir.
Yeah.
So I actually bought this. 1 second, sir. Sir, like I actually bought this. Wait, why is it still there?
You have to remove your background.
Yes, sir. I bought this book, sir. Newton's Law. I bought this in like 6th. So
Your video isn't even moving there.
I can see that. I can see. What are the
yes,
contents
sir.
of that
So
book?
it actually tells about the 3 laws of motions and motion of planets. The 3 laws of 3 Newton's laws of motion and Newton's law on motion of planets.
Very good.
It's like a story, sir. Like they explain it in a way of story where a teacher explains their students in a fun way.
Okay, that's cool. We should study it.
No, sir, it's not cool.
So I finished it twice.
Wow. Then you must be having some insight of this chapter.
Yes, sir.
Okay.
I've read it.
So first law of motion and inertia. So Newton in the first law, he described about the inertia. Okay. So first I would like to make you write, or first let us we shall discuss about this first law, and then we'll be, I guess, writing in the very next just a minute.
I'm pretty sure Sankar will become a theoretical physicist.
Why? I don't want
His
to be.
dreams.
Yeah,
Yeah,
his
in my
questions
dreams,
are
yeah.
like that.
Thank
Hey,
you, Dan.
theoretical physicist is a really good
You're welcome.
I
occupation.
don't want
Huh?
to. I don't want
So
to.
what's inertia?
I want to be an
Applied physicist.
I want to be an artist.
Yeah. Okay. So Newton's first law of motion and inertia. So today we'll just get a gist of it, and then we'll be doing the statements and all in the next class. Okay. Right. So this first law, what this first law says and what the second law says, what the third law says, I'll just explain in brief. See, what is inertia? Tell me
So
one thing.
inertia is the tendency for an object to move.
Remain at its state. Tendency of an object to remain at its state. For example,
Yes.
if you are sleeping in the morning, you are sleeping in the morning, and suddenly your mom or dad comes and then try to wake you up. Well, like, will you be liking to wake up?
No, sir.
Hell no, sir.
No.
So
That is
first
your
law,
inertia at rest. That is your inertia at rest. So like this only, everybody tries to be at its state and doesn't want to get deformed
Tries to
or
be at
displaced.
rest like us.
Yeah. So if a ball is
Like-
kept at a place, it will try to be at its place unless and until you provide any external force. If a ball is in motion,
yes, sir.
it will try to be in its motion unless and until you provide any external force. I'll say that, sir. Okay, I'll show you this. Galileo was one scientist. What he did, he first put a ball here on an inclined plane and tried to roll this out. So he saw that the ball is like just rolling out, and then it stopped after some time. Then what he did, he removed the friction. He made the surface frictionless, and he saw that the ball was just moving on with the same speed. That means friction was the
Sliding.
kind of opposing force that was making the ball stop. And he concluded that this ball will keep on moving unless and until you provide any external force. Another thing, inertia is not only moving or stopness. Okay, see, if you are throwing a ball towards the batsman, so your ball is moving at a certain distance, certain direction in a straight line, and the
Yes,
batsman,
sir.
what he does, he hits the ball in a different direction and the ball changes its direction. Another inertia is there, that the ball or any object will try to move in a particular direction unless and until you provide any external force towards the other direction. Understood, everyone? So how many kinds of inertia are there? Inertia at rest, inertia of being in
Inertia at
rest,
motion.
inertia of motion, inertia of motion in a particular
Inertia at
direction.
rest.
Are you getting my
Yes,
point?
sir.
Yes,
Yes,
So
sir.
sir.
you understood the term
Sure.
inertia?
Yes,
Yes,
sir.
Understood
sir.
the term inertia? Everyone?
Yes.
Yes, sir.
Very good. That's why I say, Tarun, you understood?
Sure.
Okay, good. Now the second law, what the second law says? Second law says that there is something called momentum. He introduced new term momentum. So let us see. I'll give you some practical example. Let's feel the physics. If any ant is coming towards you with a speed of 5 meters per second, will you be able to stop the ant by just putting your hands? By just putting your hands?
No way.
No, sir.
You won't be able to stop? If
Yes,
that
sir.
ant
If
is
I
coming,
put it before. Yes,
Sir,
sir.
it's an ant, sir. I can stop, sir. It's an ant.
But it's
Exactly.
going 5 meters per
An
second,
ant is
bruh.
coming. If an ant is coming with 5 meters per second, and if you put your hand in front of it, won't it be stopping after
Meter
striking
per
your hand?
second.
Yeah.
An ant going in a
Just
speed
let us
of 5 meters per second.
yeah, let us reduce it.
Yes,
Let us say
sir.
that 0.1 meter per second. 0.1
Yes,
meter
sir.
per second.
Yes, sir.
Then you'll be
If
able to
someone
stop
is
it.
standing, why not move at that speed, right?
Okay, please listen here. Please listen. I'm going to tell you something interesting. So will you be able to stop it?
Yes, sir.
Sir.
In the same case, if an elephant is moving with the same speed, 0.1 meter per second, can you stop him by just putting your hands like this?
No, sir.
No, sir.
You'll crush my hand and go, sir.
Will he stop? So
You
scientists
touched my
found
hand.
that there is some relation. The scientists found that there's some relation between the mass and the velocity, because in order to consider these situations where you have to stop something or where you have to initiate something like this, you have to consider both the things. You can push an ant, but you cannot push a elephant. You cannot push an elephant. Are you getting my point? So they thought that mass and velocity are to be considered together to solve the questions of forces, like what forces you need to provide to move anything or to stop anything. So that's why they introduced a term called momentum. Momentum is just a product of mass and velocity. So now we won't consider the mass, we won't consider the velocity, we'll consider the combined effect of mass and velocity, that is the momentum in these forces. Another thing, if 5 gram is the 500 gram is the weight of a bullet. And can you stop the bullet moving at 300 meter per second by just putting your hand?
No.
It will pierce
Sir,
your
we can't
hand.
stop it even
That's
if
why.
we
That's why
can, sir.
they thought that it is not the mass. It is not the mass,
But
and
it will be bigger in my hand.
yeah, it is not the mass. It
Yes,
is not the velocity. It is the combined effect of mass and velocity to consider these situations, and then they introduce the term momentum. Understood? So
Which relates both
this
mass
same
and
thing.
velocity.
The change in the Newton said in the second law, the change in momentum with respect to time, like earlier we had that the change in velocity with respect to time was acceleration, change in distance with
But I
respect to
don't
time is
get it,
velocity.
sir. Like let's say the ant goes at 300 meters per second at the speed of a
You
bullet.
won't be able to stop him. You won't be able to stop him.
Yes, sir. So the mass doesn't matter. Only the velocity.
That's what I'm
is
saying. Now
sufficient.
it is neither the mass nor the velocity. It is the combined effect of mass and velocity that we have to consider. Okay. That's what I'm saying. So we consider both the things, and then we've introduced a term, and that's why Newton said in the second law that the rate of change of momentum, that means the change in momentum with respect to time, is the force. He devised force from here. So rate of change of momentum from time. Okay. And the third law is very easy: action reaction. Okay. Whatever force you'll give in the action, same amount of force you'll get in the opposite direction as the reaction. Understood, everyone?
Sir,
Yes, sir.
Yes, sir.
So we'll be doing these things in the next class. Till then, you study these things and solve the assignments. Okay. Bye, everyone.
yes, sir.
Thank you, sir.
Bye,
Thank you,
sir.
sir.
Bye, sir.
Bye, sir.